All right. So the second one, this one, because there is a square term. Yeah. If all the linear terms, then we can use the previous formula. Very easy. But when you have a square term, then this time you need to consider. So we use that another formula we can use. Yeah. All right. So S minus A, S plus A, we will use this formula. S squared minus A squared. Yeah. The difference of squares, this formula. Yeah. Simple formula, but it can help us, get the right split. Yeah. All right, so here, this one, the first split, in the first, we take that S squared plus 1 out. Inside S minus 1, S plus 2, we can use our, previous split formula. Yeah. AB, yeah, because we arrange S plus A is negative 1, so smaller than S plus B, 2, positive 2. Negative 1 less than positive 2. So we can apply that formula. Yeah. S squared plus 1, we keep it. Yeah. Then the difference is 3, so 1/3. 3 times S minus 1 minus 3 times S plus 2. Okay. Then you multiply through after it. Then 3 S minus 1. 3 S plus 2. Okay. Then next time we need to do split. 2 more splits. All right. So let's look at the first one. Yeah. Let's write this in this order. Okay. Now we need to use the formula. Okay. So when you do it, the first one still S minus 1. The second one, you need to use S plus 1. Yeah. Then, because in this way, you need to make an adjustment, right? Yeah, because the numerator S squared plus 1, yeah, so you do some calculation on your scratch paper. S plus 1 minus S squared minus 1. Okay? Then it's 2. So you need to multiply 1/2 to cancel out that 2 at the numerator. So you will get 2 times S minus 1 minus 2 times S squared plus 1. Yeah. Then, this form friendly for Laplace transform, inverse Laplace transform, right? Yeah. So when you get some point, when you see it is friendly for the inverse Laplace transform, then you can stop there. Yeah. All right. So one more. Let's practice another one. Yeah. S plus 2 times S squared plus 1. All right. So the split should be like this. Then use the formula, the numerator S minus 2, but you need to multiply some, adjustment fraction. Yeah. But you look at the numerator, S squared plus 1 minus S squared minus 4. That's 5. So your other adjustment fraction, you need to multiply 1/5. You get 1 over 5 s minus 2, 5. Okay, yeah. Then it is very friendly for inverse Laplace transform. Okay, yeah. Although when you do inverse Laplace, you need to do further split here, further split. But that kind of split is trivial, right? That kind of split, you know, trivial. So you can handle easily. Yeah. So that is the second example. Yeah. All right. So next, another example. Yeah. So for this example, when we do split, we want to split this fraction first. Split this fraction. Then we multiply the numerator. Won't be very hard. Yeah. So this fraction, let's do factorization. Factor s squared out. So s minus 2. Yeah. Then, because there are three factors, we should take one factor out, right? So let's take one factor, 1 over s out. So inside it is s times s minus 2. Yeah, so we may like to write s minus 2 first, then s. Yeah, because our, you know, AB, right? Yeah. A is negative 2, B is 0. So A, so B 0. Yeah, negative 2 less than 0. Okay, yeah, 0. Yeah. So we can do the split. Yeah. All right. S minus 2 minus 1 over s. Then multiply that adjustment fraction. The difference is 2. Okay? So 2 at the bottom. Yeah. So we can get 2s s minus 2 minus 2s squared. Okay? Yeah. This one already friendly, right? Yeah. So we need one more split here. One more split. 1/2 s minus 2 minus 1 over s multiply 1/2. Yeah. Apply that basic formula. All right? Yeah. So then 4 times s minus 2. 4 times s. 2s squared. Yeah. Yeah. So then you multiply the numerator. After that, multiply numerator to simplification. So that part should be very easy. Yeah. So here you can see, so this method, if you can master this method, so then you do not need to use the standard partial fraction method, right? Standard partial fraction method, because a lot of A, B, C, D, okay? Yeah. Although still correct, yeah, but probably too much work. Yeah. So you can think about when you do preparation. Yeah. So if you can handle the calculation like this, so you can try a little bit. Yeah. So the goal, you try to save your time in our final. Yeah. So if it can save you, you know, let's say 10 minutes. Yeah. Yeah. 2 questions, 10 minutes. That's a lot. Okay. Yeah. Yeah. But still, I want to remind you, in the final, you can choose 3 of the questions. Yeah. So 3 of the questions, you have second chance. Yeah. Yeah. So you have second chance. Yeah. All right. Yeah. So you then another one. Yeah, this time, because this time the new denominator function product of two quadratic. Yeah, so this is a little harder, but not too much harder. Okay, all right, not too much harder. Now, how do we do it? Yeah, so here, yeah, this is the result, but I need to show you how to get it. Yeah, this is the first split. The first split. Yeah, all right. So let me show you this way. Yeah. The first split. We want to see what is this. Okay. Yeah. Okay. We want to test it. See. Because the denominator is good. The denominator is good, but numerator definitely it cannot be 1, but we want to see what's that, the numerator. Okay, yeah, cancel out. Yeah, all right. So 2 times s plus 2. All right, so you have a factor like that. Then we do division by that factor, right? Yeah. So then, when we do division by that numerator factor, so we have this division. 1 over 2 times s plus 2. Then, inside, s squared plus 1 minus plus 5. Okay? Then, let's do multiplication. One. All right, yeah. Then split. More split on 2 fractions. All right. The first one, the split, oh, sorry, no square here. Yeah. S plus 2 square. Then we use the method we used in the previous slide. S plus, sorry, minus 2, right? Yeah, because plus minus. Then multiply some appropriate fraction. So the numerator s squared plus 1 minus s squared minus 4. So it's 5. Multiply 5. Okay. So you get s minus 2. 5 s squared plus 1. All right, so that's split. Ready to go. Okay? Yeah. That one, the second one, all right. Then this time s plus 2 minus this time, you know, it's not good to use the s minus 1, right? But this time you can see, you put s there. Right. S there, then yeah. Oh, sorry. S there, yeah. The numerator, you know, after cancellation you have 5, so you need to multiply 1/5. Okay? Yeah. So you have 5 s plus 2 minus s over 5 s squared plus 2s plus 5. Yeah. So this, ready to go. Okay? Yeah. So here just show you, if you have a good control on the algebraic operations, fractional operations, then so all the splits like these examples you can handle well. Yeah. So that's the point I want to make. Yeah. All right. So if you can handle that, so then in the final, so try to use these methods to save your time. Yeah. If not, you use your ABCD way. Yeah. ABCD way, so you need a little more time. Yeah. But remember, so I give you a second chance. 3 questions. 3 of the 10 questions you have second chance. Okay? 3. Yeah. Here I can change my original idea a little bit. Yeah, because remember last time I said I ask you each one you list 3 numbers. Yeah. Now I can modify that method. I try to give you better chance. I do not ask you list 3 of the 10 questions. I just repost all the 10 questions. Then you select 3 of them to use your second chance. 3 of the 10. So you just choose. Okay, 3 of the 10 questions. If you choose more than 3, then I only take the 3 best one. Okay. If you do more than 3, I only take your top 3. Okay. Top 3 questions to replace your classroom version. Yeah. In that way, so when you manage your time, keep in your mind, so you can leave out 3 of the 10 questions. Okay. So because you have second chance. Yeah. So that's some updates. Yeah. All right. One more. Yeah. Yeah. But this one more, you can see, because we already split the bottom part before, right? So then you just multiply. Yeah. Yeah. Here, because this kind of split, I think, based on the result of the previous slide, so we can do it easily. Yeah. So here, I do not need to repeat it. Okay. Yeah. Because using the split from the previous slide, so we just do a little more work, so we can get the yeah. But this one actually we can do. Yeah. After you get this one, we can do some because square, same degree. So then we can do more simplification. Yeah. Let me just do the more simplification. Yeah. All right. Let's continue. 2 times s squared plus 2s plus 5. Yeah. Yeah. Let's take 2 out. Minus 2s plus 5. That's s squared. Okay. The second one, 2 s squared plus 1 minus 1. Okay, minus 4s. S squared plus 1. Yeah, because in this way, okay, 1 minus s plus 5 plus, okay, all right. 2 minus 2 minus, yeah, so if you put together, it's okay, okay, plus 4s. Okay, all right. Then, because 2 you can multiply inside, right? Yeah. 2 you can multiply inside. 2 you can multiply inside. So 2 cancel out. Then you have 4s plus 2 minus 2. Yeah, so you know, if you multiply inside, 4s plus 10, s squared plus 2s plus 5. Okay? Right. So the first one already friendly, right? Yeah. But the second one, you need to do one more step. Yeah. So the second one, because in order to apply the S shifting theorem, we need to write it as this way. 4s plus 1 plus 6. Yeah. So this is more friendly than the previous one. Yeah. Because this part we can use the S shifting theorem, S plus 1. Yeah. After that, then when you do inverse Laplace transform, yeah, you can apply our basic formulas. Yeah. All right, so that's the examples we need to use in our midterm. Yeah. So when you do your preparation, try to practice, okay? Try to practice, yeah, things like this a little more. Yeah. All right. Then the last part, first 5 questions, I want to give you the sample questions. Yeah. Yeah. Let me see how much time do I have. All right, 25 minutes. Yeah. All right. The first question. Solve a 3x3 linear system of ODE. Yeah. So let me give you the sample question. Yeah. Yeah. Like this. Yeah. 3x3. Okay. Yeah. Yeah. All right. Then the method is the same as the one we use for 2x2. Yeah. Just the 3x3. A little more calculation. Yeah. All right. First, we calculate. So the A matrix. We need to calculate the eigenvalues. Yeah. Eigenvalue, you need to calculate determinant. Yeah. So you can use Wolfram alpha. Okay. Yeah. So you need to know how to calculate determinant of a 3x3 matrix. Here I use some formula. Yeah. Yeah. So you can use Wolfram alpha to calculate in this step. Yeah. Because actually, yes, the Wolfram alpha. Yeah. All right. Yeah. So then you can find the 3 eigenvalues. Okay. After that, you need to calculate 3 eigenvectors. Yeah. Each eigenvalue. Yeah. Remember how to calculate each eigenvalue? You plug in. Yeah. So then. Yeah. Because when you plug in the first eigenvalue. Then you have a matrix, 3x3 matrix. Then x1, x2, x3, you need to solve this homogeneous equation. So this homogeneous, remember, the three equations, they are linearly independent, linearly dependent. Okay, remember, linear. That means one of the equation. Yeah, so one of the 3 equations is redundant. That means one of the equations can be generated by the other 2. Yeah. Okay? So you can actually redundant. Yeah. Then the 2 equations, you just choose, based on your observation, try some simple x1, x2, x3 values to satisfy those two equations. Yeah. Although you can do some, but usually because the numbers I give you usually very simple, yeah, simple numbers. Yeah. So you should try some nice integers, okay? Try to satisfy, those equations. Yeah. Yeah. After that, you can get that. Yeah. Yeah. Other than that, because if you do not calculate directly, you can still use the Wolfram alpha to calculate. Yeah. So that should be easy. Yeah. Yeah. Here I just want to see if you know the process, if you know the calculation process. Okay. Yeah. So if you use online calculator to save your time, so there is no problem for that. Okay. Yeah. But you just need to show me the process. Okay. On your test paper, you need to show me step by step. So what do you want to do? Yeah. I can see your whole process is correct. So I know you know how to solve this kind of questions. Yeah. That's the first sample question. Second, you need to solve a word problem. Solve a system of RLC circuits. Yeah. Let me give you this sample. This is the sample question. A system. Okay. 2 cycles. Okay. 2 cycles. So you should have a 2 by 2. You have, linear system of ODE, but it's a 2 by 2, not 3 by. I won't give you 3 by 3 type questions. Yeah. So just 2 by 2. Okay. All right. Yeah. So then you can, get your linear ODE system. Yeah. After that, you solve, eigenvalue. But this one is non-homogeneous. Okay. So you need to do another IP step, particular. Yeah. After you get a homogeneous IH, you need to find the IP. Yeah. So then, for the homogeneous part, you find the eigenvalues. Yeah. But this one, eigenvalues, they are complex numbers. Yeah. But for our final questions, I try to give you good numbers. Yeah. I do some experiments. Yeah. I try to give you relatively simple good numbers. Yeah. And I want to avoid complex numbers. Yeah. Yeah. But this one, original question, complex number, we need to do the calculation using the complex numbers. Yeah. Then that means you need to do more work. Yeah. Complex number, in your calculation, you need to do more work. Yeah. But I try to use simple real numbers in your calculation to save your time. Yeah. All right. Then, so we come. Then the IP part. Yeah. Other than that, because the IP here we assume IP is a constant vector. When you assume IP constant vector, you take derivative IP, it's 0. Then you only need to solve the non-derivative part is another linear equation. But you need to know how to find the inverse of 2 by 2 matrix. So this is inverse. I'll give you the formula in our notes. Yeah. Inverse 2 by 2 matrix. That formula. Okay? So here we use that formula. We can write the inverse. So inverse multiply this vector, so then you find this IP vector. Then, so you write your final solution. So that is the second sample question. So when you do preparation, just you can reasonably expect I will give you the real number solutions. Yeah. So not complex solutions. Yeah. All right. Yeah, so the remaining, yeah, because last step there is a initial condition, so you need to determine the C vector. Yeah. All right, so you know after you find the C vector, then the last step you write the final solution. Yeah. Yeah. All right, so I tried. So from my side, for all the questions, not just the one question, for all the questions, I tried to. When I design the question, I try to make nice numbers, yeah, friendly for calculation. Yeah, so do not use some messy, numbers. Yeah, because my purpose is I want to check if you know the general methods for the solutions. Yeah, so for the computation, it's not our not our main focus. Yeah. Computation, we can always rely on computer softwares. Yeah. So that part, I will not. I try to reduce as much as I can. Yeah. Computation burden. Yeah. All right, so that's the second sample question. Third one, calculate Laplace transform by differentiation. So here are the sample question I take from our homework assignment number 3. Yeah. So this is our homework assignment number 3. Yeah. And I haven't graded, but I will grade it, complete grading today or tomorrow. So in our Thursday's class, so you will have the results of homework assignment number 3, and I will make some comments. Yeah. So. Yeah, so then we can use that for our preparation for the final. So this one, yeah, requirement by that differentiation formula. Yeah, so you try to follow the requirement. Yeah, only when you cannot make it. Okay, so if you follow the requirement, you cannot get a solution. Then I allow you to use any method to solve. Yeah. But if you use a non-requirement method, I need to take 1 point off. Okay? Yeah. For that requirement thing. Only 1 point off. Yeah. All right. Yeah. So here these two preparation. So the differentiation formula is this one. Okay? Yeah, because you multiply that t, when you multiply that t, that is just the take derivative of this capital F function. Okay? Yeah. Capital F function. Yeah. So this is a capital F function. Then, based on our differentiation formula, we have applied this formula. Okay? Yeah. So you get the answer. Okay. So that's the differentiation. Yeah. Then the next one, you need to calculate inverse Laplace transform by the integration. There's another our homework assignment number 3. Another question in homework assignment number 3. So this one. Okay. So that question, because I haven't graded, yeah. So in my solution file, I gave you 2 solutions. Yeah. The first solution not by this integration formula, but the second one is by this integration formula. Yeah. So here I took the second solution. Second solution following the requirement. Yeah. All right. So we have this formula. Yeah. Then g function is that. Okay. So this is g function. Okay. Yeah. All right. So then we calculate inverse Laplace transform of this. Here you can see, there is an integration relationship, but we calculate the inverse of the integration result. Yeah. So then we can find solution easily. Right. Then we can apply the, integration formula. So the inverse Laplace transform, because we already know it's that. Okay. All right. Then this side, we go back to this side. There is a, inverse Laplace transformation of the transform of the integral form. Okay, integral form, by this integration formula, we should use this little gt divided by t. Yeah, little gt divided by t, but we know the result, right? This is the result. Okay, yeah, from this one we know the result. Then that means we can calculate the gt from this equation. Yeah, yeah. So that is this. So that's the sample question number 4. Okay? Yeah. So I want you to practice these two formulas. Yeah. Differential formula, integration formula. Okay? Yeah? Yeah. Yeah. So from these two examples, yeah, I want to make my final question similar to these two examples. Similar difficulty. Yeah. So if you can handle these two sample questions well, yeah. So I will see in your homework number 3. So how well you did in that assignment. Yeah. So then I can see. Yeah. But after your practice, I hope you can do better than that. Yeah. Yeah. So these two questions, you can get them easily. Yeah. All right. So the last sample question today, yeah, yeah. Number 5, yeah, that's the power series solution. Yeah. Power series, the sample question, I still use the homework assignment number 3, because this example, we in this Frobenius method, it's case 1 example. Case 1 example. Yeah. But in my plan, I try to do a case 2 or case 3. Okay. But I haven't found the appropriate example. So I will leave it to Thursday. Yeah. I hope on Thursday, if I can find appropriate example on Thursday for case 2 or 3. Yeah. So Thursday first, I will try this idea. I don't know if I can find it or not. Case 2 or case 3. One of the, I just select which one easier. I want to select the easier case. Yeah. And I want to make the coefficient number friendly for calculation. So when you do calculation, not very messy. Okay? Yeah. Not very messy. Yeah. Case 2 or case 3. If I cannot find good example in case, yeah, because after I try a few times, still hard to find a nice example. So then I just take the case 1. But the case 1, when I ask you to do it, I won't ask you to do a basis of one. Basis because you need to find 2 solutions. I only ask you for one solution to save your time. One solution. Okay? Yeah, because second solution is similar. You basically do the similar calculation as the first one. Why you repeat this, the same thing, right? So if I choose case 1, I only ask you to calculate the first solution. Okay? Yeah. So that's something I will let you know on Thursday. On Thursday we will know, the detail of this sample question. So here I put this temporarily, okay? So this is a temporary example. Yeah. Yeah. If I can find appropriate, I will replace it in our Thursday's class. Yeah. If I can find a good sample question, then I will replace it in our Thursday's class. Yeah. So then I will give you the remaining 5 sample questions from the Fourier analysis topic. Yeah. Yeah. So then you just prepare, based on these 10 sample questions. So you do your preparation for the final. Okay? Yeah. All right, so I want to stop right here today. Yeah, so if you have any question, so you can ask me. Yeah. If no question, then just see you on Thursday. Yeah, Thursday we still meet on Zoom. Okay, so we will not go to the classroom. So we will still meet on Zoom like this. Yeah.
I have another question.
Yes. Uh-huh.
Well, one, when you find out what route, what time, what day on final is.
Oh yeah. Oh sorry. Yeah. So yeah. Yeah. Actually. Yeah. I will post the classroom. Yeah. Yes. Yeah. Good. Good. Yeah. You remember me. But the time, same time. Okay. This classroom is different. I will tell you the classroom, and yeah, I will post tonight. Yeah. I will look at my email. Yeah, and post it tonight. The time still from 6 to 8. Yeah. 2 hour. That same 2 hour window. May the 6th, Tuesday. Yeah. 1 week from today. Yeah. Next Tuesday from 6 p.m. to 8 p.m. Yeah. The classroom, I couldn't remember. Yeah. So, yeah, but definitely I will look at my email and I post the building. Yeah. I post the building and the classroom number. Yeah. In the announcement. Yeah. That's first question. Yeah.
If the final is 10 questions,
Uh-huh.
I think he said something about, like, we choose 2 to do at home, or you don't choose.
Yeah, 3, right. I just said before, this time you do not need to choose, okay? But when you manage your time, you know, because there are 3 questions, you have second chance. When you do your time management, you can leave 3 questions out. You can focus your time on 7 of the 10 questions if the time is very tight, okay? Yeah, because after you get home, I will post all the 10 questions again in Canvas. After you download, you just choose your 3 questions. Okay? Yeah.
And then send them like a little update.
Right. Then you submit. Okay? Submit from Canvas. I only choose your top 3 questions to grade. Okay? Yeah. Yeah, I believe most of you will just do 3 of the 10. Yeah, I said in case if some students do more than 3, but I only count the top 3. So I will not. That means I only give you second chance for 3 of the 10 questions, but not 4, not 5. Okay? Yeah, that's the rule. Yeah, that's the new change. Yeah. All right. Okay. Great. Yeah. Other students, any question? Yeah.